And okay, we are continue to dig into interesting topics, listen our amazing speakers, and the next one will be Concurrent React 18. I might do it later. That should be presented by Mykola Yenin, or will be presented. Mykola Yenin is senior software engineer that has more than 5 years experience in web development. He also doing some teaching and mentoring and addicted to understanding the depths of things. So let's proceed and let's listen, Mykola. Hello, Mykola.
Hi.
Hope you
Hi.
have a great mood.
Sure. Nothing to complain about. I'm in a great mood today because I'm glad to be here. And I hope I'm gonna talk about Concurrent React and some of details. And I hope you are in a good mood today too. You are in a mood to for getting new knowledges. And I will try to give you something new. I hope I will do. So let's jump right to the business because we have covered pretty much, but we don't have much time. Let's start with the purpose of my talk. I would like us to understand what is the main bottleneck in the world of high-performance front-end applications, see the way how React solved this issue, learn some practical tricks, understand how React concurrent features work, and what actually the problem of all the modern web applications, front-end applications. No, it's not Google Chrome DevTools, as you might think at first. The big problem is long-taking CPU tasks. And why actually it's the problem? Because browser executes all the JavaScript tasks, and just after this, it can start doing something that's related to rendering process, updating the UI, and show the new images to our user. And that is a big problem because if browser stacks on executing JavaScript, it's impossible to show new content. Also, problem is that when JavaScript is being executed, a long task that is not split, it's impossible to handle events. So user feels our application unresponsive, and it's like a huge problem because of single-threaded JavaScript nature. So what do we have? We have long task. Long task is equal to unresponsive application, bad user experience, and of course, if user experience is bad, we have sad user, and nobody wants to have sad users. It's like a big problem. So we have problem to solve. We have long-taken tasks. We have plenty of user events. We have browser network events, user interface updates like styler calculation, layout paint, etc. We want to achieve at least 60 frames per second, so our user experience will be responsive. And the question, how can we do it? The answer is pretty simple. We need task splitting. Also, we need batching, like grouping of tasks. We need prioritization. And we need scheduling. And this stuff, it's not just related to front-end applications. Even you can see some examples in real world. So I'm gonna try to give you some. Let's imagine that you have plenty of tasks in your real life, and you need to handle all of them. And I think it makes sense that first you will prioritize them. So you will prioritize them in importance. The second step that you might do is plan them. You will find the best time to handle this task. And for example, if you need to buy some food for your dinner, most likely you will do it way back from your office to home. So you will batch these tasks, and it will make you more efficient in implementing those tasks. And actually React team realized these issues, and they came up with the solution. They came up with the solution a few years ago, and like actually in React 16, the new algorithm that like allows us to make this stuff was released. But basically, only in React 18, we got stable API from React team that uses like all the power of this under the hood stuff, under the hood algorithm, data structures, and set, etc. So we will talk about it a little bit better about React Fiber. What is the React Fiber? It's a new algorithm. But for the first, I would like to start with scheduling. And actually with some scheduling tricks that you might use in your real life, for example. I hope it will be interesting. So everybody knows that if you want to schedule something in the next tick-off event loop, you will do it using setTimeout0, and the delay of setTimeout0 is about 4 milliseconds. It's okay, but there is a hack with message channel API, which is much faster. I will show you two benchmarks. Actually, this code does pretty the same, but on the left side, we can see a benchmark of setTimeout, recursive setTimeout, and we run it for 1000 times, and actually we have a callback that only increments current run each time. And then we call setTimeout recursively. Here on the right side, we have the same, but using this message channel API. And let's jump to the results, the interesting part. So we have 1000 runs. Like I've done this performance working on machine MacBook Pro, and if you take a look at results, it's pretty interesting. Recursive setTimeout showed us about 5 seconds, but at the same time, recursive message channel took only 14 milliseconds average. And I think it's incredible result. It's a it's a huge difference. Of course, it's not really useful in most of cases, like regular cases in your work routine. But if you need to schedule something and you do not want to waste any millisecond of your time, I think you might start thinking about recursive or not recursive, but just message channel API. So what is about support? Everything is great here, as you can see. We will jump to another slide. And the next interesting practical trick is better JS scheduling with some interesting API. Navigator scheduling is input pending. This is a pretty new API, and what does it do? The input pending API allows for JavaScript to be able to check for input without yielding to the browser. I will show you what it means. We can see two examples. The first one is while true loop, and it makes sense that it's in infinite loop. The second example uses this navigator scheduling is input pending. So when this JavaScript while loop is being executed, and at the same time, user creates, and user interacting with our application creates some event, input event, like not network event, input event. We can get this value from inside our JavaScript execution, and it will return true or false, whether we have some pending tests or we do not have, and it will break this while loop when some event happens. So it doesn't have so good support here, as you can see, but anyway, you might try it out. And by the way, the React team also uses this API for better scheduling. So welcome React Fiber. what is React Fiber? React Fiber is a main and central entity in React. It's an object which represents our React components and associated with them DOM nodes, and has all the information about what should React do with it. And thanks to React Fiber, we can split work into chunks, and we can also prioritize and batch units of work. Before React Fiber, before React 16, React used stack reconciliation, and that led to blocking of the main thread for layout animations. It was impossible to split work into like smaller chunks to fit in render frames. It was impossible to pause, impossible to react on user events rapidly, and it was like a big bottleneck. So, React Fiber 3. Let's imagine we have some tiny application, and we have application component, filter, input, and list. So for this particular React application, React will create such kind of data structure, and it's called React Fiber 3. These are fibers. So we have fibers, and relationship to each fiber with each component is 1-to-1. So app fiber for app component, filter for filter, etc. And you can see that these fiber nodes are connected between themselves using some links, some linkings. You can see main linking properties like child. So it says us that filter component is a child of application component, and it has return. So we can see from that input component is being rendered by filter component. And also we have sibling property. It means that input and list, let's say, on the same level in the DOM structure. And using these properties, actually it's called linked lists. And usually this, and using this linked list, we can traverse all the tree from the very top, from the very bottom of the tree. Usually, not usually, React uses two kinds of trees under the hood. We have current tree. This tree, these fiber nodes, represents current DOM. It represents that something that we can see on our screen, on our UI in browser. And when the state is updating, when we update the state, React creates work in progress tree. Work in progress tree, it's actually a copy of this one, and React does like the process which is called reconciliation using these two trees. It compares all the changes using this work in progress tree. And when React is done, React commits these changes to our UI, to DOM, and it marks this work in progress tree as the current one. So now the current one is going to be this one. I hope it makes sense for you, but we will talk a bit deeper later about this. By the way, this process is called double buffering. Double buffering is a term used to describe a device with two buffers. For example, with graphics, double buffering can show one image or frame, while a separate frame is being buffered to be shown next. Actually, we can see double buffering here. So we have one buffer, it's current tree, that is represents our current UI, and we can see it, and the another tree which is computed in the background. So fiber interface. What is the fiber? Fiber is a plain object, and it has as each object, every object, fiber has some properties on it. So I add some of these properties. It's not all of them, but I think it's some of the interesting ones. We have some linking properties. We already have seen it in the previous slide. We have type, is there a solid function or class associated with this fiber? Actually, it's that code, that function or class component that we write, implement in our React code. We have tag. Tag, it's just numbered. It could be a function component, class component, memo component, context, etc. There are plenty of tags. Memorize the state as all the data that React stores for particular this component, this fiber, all the state actually. Update queue, it's a queue of state updates and callbacks. It's an object that consists of callbacks that should be run one by one. For example, if we have use effect inside our component, and each callback from this use effect will go to this update queue, and it also connected using linked list. So we have three use effects, and we have three callbacks that are connected by link the next effect, and this this linked list is cycled. So the last effect callback will link to the first one. Okay, priority. It's we will talk about this a little bit later, but these are two main properties. We will discuss it. Dependent props, I hope it's pretty clear here. So it's some data that React's component is waiting for from the top. And alternate. What is alternate? Alternate is the same fiber, but from alternative tree. So, for example, for this fiber, the alternate is this one. At the same time, for this fiber, alternate is this one. So it helps React connect like this to find something that change in this current tree. Okay, let's jump next slide. React working cycle. Each application has its own has its own working cycle. What's about React? We usually update the state. The reconciliation comes into play, creating work in progress tree. The process of reconciliation, committing the final result of the reconciliation to the DOM, and mark work in progress tree as the current one. Here is a simple working cycle of every React application. Let's just take this working cycle, but a little bit deeper. We have perform unit of work function. It's like a real function from React source code, and this function is one of the main functions of the reconciliation process. So this function is going to be called for every single fiber node in the whole React application tree. For example, if you set state, it doesn't matter where you set state. For example, if you set state in the very bottom, very nested component, anyway, React will create the in progress tree, and it will start perform unit of work and call this function for each fiber from the very top. I hope it makes sense. Perform unit of work consists of two functions. The first one is begin work. This function is called first, and it starts from the very top of the React fiber tree. It's called for the first component, for the first fiber, and it goes to the bottom, like this. And in this inside this function, React actually calls our code, so our functional or class components. So our code is is being executed here. After that, when React finishes, it starts from the very bottom component, from the very bottom node, and starts calling complete work. And it goes from the very bottom component to the very top component. So inside this function, React creates and updates DOM nodes, but keeps everything in memory. It doesn't commit it to the real DOM, and we cannot see any changes here. And this file, this phase is interruptible. So when React performs one unit of work for one particular fiber, it can decide not to perform a unit of work for the next fiber. Probably it's not the best time now, or we have some user events, so we can pause, we can cancel, and it's really powerful thing. It's a non-interruptible phase. It's commits and root. So after the reconciliation is finished, React commits root and add changes to the DOM. And uncommit root hook, that's callback that fires after React commits changes to the DOM. In this phase, React runs unmount effects and mount effects, etc. And the order, the first React run unmounts effects for nodes and components that were unmounted, and after that run mount effects. And by the way, for example, layout effect is being called not in this uncommit root phase, but in this phase. That's just one interesting difference between these effects. Okay. Update using set state. We have let's just try to take a look at this slide, and we will understand like much more. Some event happens, so user interacts with our application. React creates an update object. Update object has lane and action. Action actually is like setting the state, the value of the new state. Lane is the property that represents priority of this update. We will talk about this a bit later. So each update has lane, priority, and action. After that, React schedules an update. Makes sense. And after that, it calls workLoop sync, workLoop synchronous. And when we like update the state using like plain set state, we always React always calls for this function. And what does this function do? This code is completely copy-pasted from React library, and it performs work without checking if we need to yield between fibers. So while we have work in progress, we perform unit of work on this work in progress. Work in progress in this case, it's not the whole React fiber tree, it's just one particular small tiny fiber. So like we traverse without yielding to the browser, so it's synchronous. Using set state, we do not actually like using plain set state. Usually, we do not like get all the powerful stuff provided by React Fiber with pausing and etc. Update using start transition or use transition. Event the same, update the same, like action and lane, but lane is another one. In this example, we had lane, and the value of this lane is equal to 1. It's just 1. 1, it means the highest priority. It's like synchronous. So React in this case calls for workLoop synchronous. Using start transition, React schedules update with lane that is differs from the 1. And React calls workLoop concurrent. WorkLoop concurrent. This code is copy-pasted from the React repository. It performs work until scheduler asks us to yield. So now you can see if we have work in progress fiber, we perform unit of work, but we also check for maybe we should yield. And you remember like this interesting function is input pending. By the way, is input pending API is used inside this function. So now we can pause our work or cancel. For example, if another event has happened, another event has happened, so React takes this event, it realizes this new event has priority, the highest priority, and it starts doing the work for handles the new event, the new update, and it will come back for this current a bit later. So scheduler. It's a tough part. It's a hard one. Unfortunately, we don't have much time to cover everything, but I will try to emphasize main thing, and also will attach interesting pull request. So lane is a 32-bit representation of task and reconcile time, and the actual code for lane is follows. So we have different kinds of lane. No lane means that React and lane, each fiber has its own lane. And for example, if there is no lane on fiber, it means that it's nothing to update for this fiber. Sync lane, it's the lane with the highest priority. It's value of 1. And it means that React should perform this work first, and in synchronous mode. And all the other lanes, these lanes use React concurrency. So they use concurrent working loop. Why does React use lanes in form of bitmasks? Bitmasks are faster, less memory consumption. Lanes can express many distinct task threads with a single 32-bit data type, and it has we can represent absolute priority value over relative expiry time approach. Unfortunately, we don't have time to cover this, but I attached this pull request as initial lane implementation, and it has pretty good description about this. So, and now we have some knowledges, some theoretical knowledges, and I will show you like some examples, code examples, and I hope it will make more sense for you. First of all, when we need to use like this new API, this new concurrent API, we need to use it in case if we want to separate some parts of updates on our UI, and usually split into urgent and lightweight ones on one hand, and for long taking and less important on another hand. Let's jump into the code editor, and I hope it will make more sense. We have a tiny application. Here we have sync example. Inside sync example, we have input, just plain input, and list component. List component generates 10,000 items and just iterates over these items and returns value passed from props inside div. We have set state and we have handle input change callback that actually handles the setting new state. And what's like we can see here. If I typed in something slowly, everything works not bad. And I also use like MacBook Pro. It's like a good performance. But if I type in something multiple times and pretty frequently, you can see it becomes really laggy. And as user, I do not want see this because I type in something into my input and it doesn't react. So it's a really bad user experience. And what is going on here? We updating the state using set state, and it uses workLoop synchronous, so we cannot yield when the new event is happening. So we perform our work synchronously and cannot stop executing this in case of new event. But let's jump here, comment this line of code with typical example, and try to see what actually is going on inside concurrent example. Concurrent example does pretty the same thing, everything the same. I would like to emphasize your attention on like this two new lines of code, like new state, and use like transition hook. Actually, at this place, use transition doesn't do anything. The magic is going on right here. We have handle input change callback, and as you can see, we separate our input and our list by value. So we pass value from this just plain state to input, and we pass transitioned value, like another value of state, to this list component. And what is going on here? When we trying to type something in, like let's first check how it works. Slowly is great. And so as you can see now, when I click something, like when I type in something really fast, like the input is dating really fast, and it's great that I can see that like browser and my application it is still working. But at the same time, the whole list is rendered with some delay, and it's not critical for me because actually I feel my browser, I feel my application responsive while I typing. So what is going on here? React creates for set state, for set value, it creates an update, and it has the priority of 1, the synchronous priority. Then we call start transition function, and start transition function says that the next setting of the new state will be with priority, for example, 8. It's like some sort of transition priority. And React has these two events inside its queue, its priority queue, and it will take the one with the higher priority. In our case, it's just synchronous setting value, and it will perform it first, and just after that it will come to another one, will take it and start executing it, but using this workLoop concurrent. And as you can see, React starts executing this task, and at some moment the new event has appeared. So I typed something. React stop executing this. React also, one more time, React gets the event from set value with priority of 1. It's the highest priority. It will take this first, and it will immediately show us result. So I hope now, and just after that, it will get back to this task, this set transition value with the priority of 8. So the main thing that using this approach, we say just we want to split something from something light. For example, input updating is pretty fast operation. It would be silly to wait for updating the input while the thousands of items render at this time. So this approach allows us to separate different parts of our UIs. I hope it makes some sense for you. Let's back into the presentation, and it's time for some conclusions. And I would like to start with this slide. You can see Burj Khalifa. It looks amazing. It's a great building, and everybody knows it and likes it. But under the hood, we can see something like this, and it's impossible to build something really powerful, beautiful, something that matters without understanding of these deep details, like this backbone and fundamentals. I hope it also makes sense. Actually, I think we are running out of time, and I think it's pretty it from my side. I was glad to perform in front of you. I hope you found out something new and interesting from this talk, and I also hope that you have some questions, and I really hope that I will be able to answer it. Thank you.
Thank you. Great presentation. And I really like that you dig so deeply to understand how it works under the hood. That's great. And yeah, questions. Guys, you can post your questions in our Discord channel. And so I can read them for Mykola. And of course, we can join voice channel in Discord as well. There is few questions that I have at the moment. The first one, it will be from my side. Your presentation breaks down the myth that JavaScript developers don't need to learn algorithms and data structure. And what would you suggest for someone who just might do it later, who's still just waiting for some, I don't know, right time to start learning algorithms and data structures?
It's a really interesting question. It's really hard to answer. I started digging into it when I realized that it's one of my weak sides. So if you have something that you understand, you do not really understand well, you need to emphasize your attention on this and try to improve your skills, improve your knowledge, become a better version. And of course, as I already mentioned, understanding of fundamentals allows you to use this high-level API and this high-level stuff much more efficient with the understanding why. So it's not just the case that you need to implement something, you can implement something like you can touch your nose like this, or you can touch your nose like this. And the most efficient way like doing is like this. And algorithms and data structures, actually, it's like the core of programming, like computer science. It's one of the most important things that you have to start with.
Yeah, thanks. That's great explanation and recommendation. Touching your nose, that's for sure true. And another questions: do you use React 18 at the moment, or maybe there's plans to migrate?
We are in progress of like migrating. We use like in production we use React 17, but we are right now we are in the progress of migration to React 18.
Okay, thanks. There is also a question: when you first had to use concurrency?
Had to use concurrency when I first. As I already said, unfortunately, we haven't used it in production now, and I do not deal with React 18 and concurrency every day. And this example that I showed you, actually, it's not something from real life. Usually, you implement such types of things using your like backend API. But anyway, you will start thinking about using concurrency when you have like a big amount of components. It's the first thing. You have a big amount of components for like, and you have large updates. When you're setting the state, and you realize and you understand that it will lead to a big amount of work, and you just need to understand what is like the most important part for the user at this moment. And that's like actually it's hard for me right now to give you like maybe like exact practical example. But anyway, I hope I answered.
Maybe in future when you will have more experience with React 18 and you can play with.
Well, by the way, concurrency, or like suspense also is something that was impossible without concurrency, without this mechanism to prioritize and pause some like different pieces of work. So using suspense, usually you use concurrency.
And do you have something like the most interesting feature that comes with React 18 that you are waiting for?
With
like maybe
React
15.
It will be really interesting when off screen will come into play. I'm really waiting for off screen. This API is pretty that I showed you is pretty interesting, I suppose.
Yeah, that's true. And of course, as you mentioned, a lot of performance and how to track it. Maybe you have some suggestion about tools that we can use to check. Of course, I hope everyone knows React Dev tools and Profiler, but maybe you have something like some extra.
Some extra. Of course, we have React Profiler, which is like pretty helpful. Performance. Actually, React is pretty fast by itself, and sometimes people start like using these memorizations or like different tries to like improve this performance. But the main problem is that I will answer. For example, if you have updating your state, and usually when you're setting state, like components render multiple times, and it's not a big problem that components render multiple times. The big problem is that the execution of this one particular component is too long. So it's the case. So you need to like try to make your component code not like smaller. So without like hard computation that are going to fire each time, and you need to group your state. So it's like really it's a great topic, but we need one more presentation for this topic.
Okay, yeah, you're right. And we're just in time, and I think we can jump into Discord voice channel. So everyone who would like to can join. And at the moment, we'll have lunch break. It will be about 40 minutes. So see you later at the next topics and the next presentation. And
Thank you all,
let's jump
guys.
into Discord. Thank you once again for presentation. That was great.